So today is just going to be a quick video on the Pythagorean Theorem. We're going to talk about what it is, the proof that Pythagoras himself did for it, and then how we can derive the distance formula for the Pythagorean Theorem. So first let's talk about what it is. Basically all it says is that a squared plus b squared equals c squared, which means that the sum of the squares of the two legs of a right triangle equals the square of the hypotenuse. The hypotenuse is just the side of a triangle that's right across from that right angle. So on my left over here, we have the setup for the proof we can do for the Pythagorean Theorem. And what we can do is we can talk about two different ways that we can find the area of this shape. And then, in doing so, we can find the relationship between A, B, and C. So what we see over here, we have A, B, A, B, A, B, A, B. So it's a square. And then it's made out of four same of the same right triangle. They're put together in different places so that they can form another square in the middle. So if we want to talk about the area of this shape, well, we know that area for a square is length times width. And for a square, all the sides are equal. So really, it's just one side squared. So one side of this shape is a plus b. So I'm going to write a plus b squared. So that's how we can find the area of this shape. But there's another way we can find the area of this shape. We can say that the area is also equal to the area of all the triangles plus the area of the square in the middle. That will also give us the area. So we can set this equal to what I just said. So we can do 4 times the area of a triangle is 1/2 times base times height. Oops. So 1/2, my base can be A, and my height can be B. They're interchangeable. Plus the area of the square in the middle. So this is just c by c, so it's c squared. Now if we multiply this out, it's okay if you don't know how to do that. I'm just going to go ahead and tell you that it's a squared plus 2ab plus b squared. And that's going to equal 4 times 1/2 is 2. ab plus c squared. Now we can subtract 2ab on both sides. So that's going to cancel this out. And we're going to get a squared plus b squared equals c squared. So that shows us the relationship between the legs of a right triangle. Okay. So rules like the Pythagorean Theorem apply to something called Euclidean Geometry. And basically all that says is that you have 2 or 3 dimensional space, and you have coordinates for each dimension. So if you have like the xy plane, you can have an x coordinate and a y coordinate. And it also says that you can have a distance formula to find the distance between 2 points. So that's what we're going to talk about next. So the distance formula, I think it's actually easier to remember when you know where it comes from, because there is a lot involved. So we have a coordinate plane. I'll make that a little bigger actually. Coordinate plane. We have our x and our y. Now this won't be the scale, but I'm just going to go ahead and do this. So this will be 3. This will be 9. We'll make this 2. And we'll make this 4. So we have our plane. Now we're going to put a point right here at 2, 3. and we're going to call this point, call this point A, and we're going to have another point right here at 4, 9, and this will be C. So if you wanted to find the distance between these 2 points, well, something we can do is find the intersection, which would be right here at 4, 3, between A and C, and we can make this into a right triangle. So I'll do this right here, and we'll call this intersection H. So now let's talk about what if we wanted to find the distance between here and the distance between here, because knowing the lengths of these 2 sides can help us find the third one. Okay, let me switch colors. Now let's talk about the distance between 2 points in the horizontal direction. Well, A and H lie on the same horizontal plane, so we don't even care about their y values. We just want to know the absolute value of the distance between these 2 points. And we can define that as x of A minus x of H. Take the absolute value of that. And the reason we have that absolute value is because 2 minus 4 is negative 2, but it's not a length of negative 2, it's just 2. So the absolute value tells us just the distance between 0. We don't care about if it's negative or positive. But this will make the distance positive. So we know the distance between A and H is 2. Now we want to find the distance between C and H. Between C and H. It's basically the same thing, but now we only care about y values, because they lie on the same vertical plane. So we just want to know the distance between here to here. We don't care about negatives. So we do 9 minus 4, or 4 minus 9. We take the absolute value, we're going to get 5 either way. So now, we could just do 2 squared plus 5 squared equals c squared. But what if we actually want to find a formula for this? Well, since we know the relationship between these 3 sides, we can say that the distance between A and C equals, and one thing I do want to point out before I keep doing this, so if we say a squared plus b squared equals c squared, then we know c must equal the square root of a plus b. Because if we square root both sides, then we can get c all by itself, and then we have the square root of a plus b. So going back to this, so the distance between a and c, that would equal the square root of, well, what did we do right here? We did the distance between the x values. So we'll say the distance between A and H and I'll just put the square right here. We're going to end up taking the square root either way. Plus, well, we have our other leg, the distance between C and H. And then we can actually define that with what we have above. So we can say, well, that is equal to the square root, oops, it's hard to draw with this, square root of the absolute value, the x value of A, minus the x value of H, and we're going to square that, plus the y value of C minus the y value of H. Sorry, that C does not look very good. Okay, so now let's talk about these squares that we have right here. Actually, I'll add the square right here just so you can see this a little better. So we took the square root of c squared and the square root of a squared plus b squared. And that's exactly what we have over here, but we have these absolute values. And really, if we're squaring a value, it's going to come out to a positive number no matter what. So these absolute values are not going to be necessary in our final equation. So we can just change those to parentheses since we're squaring it. So we can say that the distance between A and C equals XA minus XH squared plus YC minus the Y of H squared. Now we're almost done. There's just one thing left that we have to do. So we have this H right here. And really, if we're going to find the distance between A and C, we don't want that H because it's not really included in the distance between A and C. We just made that up so we can come up with a formula. But we can say that the Y of A equals the Y of H because we just want A and C. Right? The Y of A equals the Y of H. They lie on the same plane. And we know the X of C equals the X of H, right? Like we said, they lie on the same plane. So what we can do here, I'll just go ahead and erase it since I'm running out of room, is we can erase the H right here, and we can replace it with C, because we defined that they have the exact same X value. And then over here we want to get rid of this H. So what we can do is replace it, oops, let me change my color, replace it with A. And that is the distance formula as we know it. So the distance between A and C will give us this. So today we've been over what the Pythagorean Theorem is, what it tells us. It tells us that the relationship between the legs of a right triangle and the hypotenuse. We looked at the proof for it, how we can figure out the relationship between the three sides of a right triangle. And then we talked about how we can use that to derive another equation, which is the distance formula. So thank you for watching, and I'll see you next week.